Hello students, we're discussing the histology of bone tissue. Now, bone is a specialized connective tissue with extracellular matrix that contains calcium salts. It consists of cells and extracellular matrix. It has three basic components: cells, fibers, and ground substance. The functions of the bone tissue are that it supports and protects the vital organs. It is a storehouse of calcium and phosphates. It performs hematopoietic function, that is production of blood cells. Periosteum is a layer of connective tissue that covers the external surface of the bone except at the area of muscle attachment and the area covered by articular cartilage. It has two layers: outer fibrous layer and inner cellular or osteogenic layer. Endosteum is a membranous layer that covers the internal surface of the bone that faces the marrow cavity. It has a single layer of osteoprogenitor cells. Let us now see the different cells of the bone tissue. Osteoprogenitor cell. It is a stem cell arising from mesenchymal tissue. It gives rise to osteoblasts that then form the bone tissue. These are flattened cells with elongated or oval nucleus, and they resemble fibroblast cell. These cells are numerous in fetal life and childhood and decrease in number as age advances. This here is a diagram showing you the osteoprogenitor cell, elongated flat cells with elongated or oval nucleus. These cells are present in the inner cellular layers of periosteum, endosteum, walls of Haversian and Folkman's canals, and their function is that they give rise to osteoblast cells. The second cell is osteoblast. These are bone-forming cells derived from osteoprogenitor cells. These are cuboidal or polygonal cells with oval euchromatic nucleus and a basophilic cytoplasm. Nucleus is placed eccentrically away from the bone-forming surface of the cell. This is a diagram of the osteoblast cell, where we can see that each cell is cuboidal with an oval nucleus which is eccentrically placed, and it has basophilic cytoplasm. The osteoblast cells help in synthesis of type 1 collagen fibers, synthesis of bone matrix proteins like calcium binding proteins, glycoproteins, and proteoglycans, and they secrete alkaline phosphatase. The next bone cell is the osteocyte. This is the mature bone cell trapped in the lacunae or spaces in the bone matrix. They are derived from the osteoblast cell. These are oval cells with cell processes, having an oval nucleus with an eosinophilic or light basophilic cytoplasm. Cell processes are trapped in the canaliculi within the bone matrix. This is a diagram of osteocyte, where we can see that each cell is oval with an oval nucleus and numerous cell processes. The functions of the osteocyte is that they maintain the integrity of the bone and they help in remodeling of the bone tissue. The next cell is the Osteoclast cell. This is a large multinucleated cell with eosinophilic cytoplasm that helps in bone resorption. They are derived from granulocyte macrophage progenitor cells, or the GMP cells, and these cells also give rise to the granulocytes and the monocytes. This is a diagram of an osteoclast cell, where we can see that each cell is large multinucleated cell. The functions of the osteoclasts is that it helps in bone matrix removal or reabsorption, and synthesis and secretion of hydrolytic lysosomal enzymes. Bone matrix. This consists of fibers, ground substance, and minerals. Fibers and ground substance are organic components of the matrix, whereas minerals are the inorganic components. Fibers seen here are type 1 collagen fibers synthesized by osteoblast cells. The fibers are embedded into the ground substance and are arranged in layers called lacunae, constitute 90% of the bone matrix. The function: collagen fibers provide the tensile strength or resilience to the bone tissue. Ground substance: small quantity of amorphous ground substance which constitutes 10% of the bone matrix. It is made up of protoglycans, glycosaminoglycans like hyaluronic acid, keratan sulfate, and chondroitin sulfate. Also contains adhesive glycoproteins. Minerals. These include calcium phosphate, which constitutes 85%, calcium carbonate, calcium fluoride, magnesium, sodium, etc. These form needle-shaped crystals that lie parallel to the collagen fibers in the lamellae. Growth of the bone. Interstitial growth occurs at the epiphyseal plate where bone replaces the hyaline cartilage. This increases the length of the bone. Appositional growth increases the girth of the bone. Remodeling occurs as the bone is resorbed and replaced by new bone. Classification of bones. Based on the gross appearance, bones are classified as compact bone and spongy bone. Based on microscopic appearance, they are classified as woven or immature bone and lamellar or mature bone. Compact bone. Outer surface of the compact bone is covered by periosteum. Inner surface of compact bone is covered by endosteum. Lamellae are arranged in 3 different patterns: Haversian system of lamellae, interstitial lamellae, circumferential lamellae, which again have outer circumferential layer and inner circumferential layer. Haversian system of lamellae. These are structural and functional units of a compact bone, also known as osteon. Each osteon has a central Haversian canal surrounded by concentric lamellae. Haversian canals run parallel to the long axis of the bone and contain loose connective tissue, capillaries, nerves, and lymphatics. Each Haversian canal is surrounded by 5 to 15 concentric lamellae. Between adjacent lamellae, small spaces, that is lacunae, are present, which contain the osteocytes. Each lacuna is surrounded by radiating canaliculi that connect adjacent lacunae. Canaliculi contain the cell processes of the osteocytes, and they provide nutrition to the osteocytes from the capillaries of the Haversian canal. Lamellae also show presence of collagen fibers, which are arranged parallel to each other or perpendicular to each other. Folkman's canals connect adjacent Haversian canals and provide passage to periosteal vessels and nerves to reach the Haversian canals. They run perpendicular or oblique to the Haversian canals. Transverse section of compact bone. Herein, the Haversian canal appears as an oval or circular opening or hole surrounded by concentric lamellae. Folkman's canal appears as horizontally or obliquely running canal connecting adjacent Haversian canals. This here is a low power view of a ground section of bone, and that's why it is not a stained slide, it's an unstained slide. And what we see here are the Haversian systems or the osteons, where we see that each osteon centrally has the Haversian canal surrounded by the layers of concentric lamellae. This is a stained section. What we see here again are a number of Haversian systems or osteons having the Haversian canal at the center, and that is in turn surrounded by concentric lamellae. This is a high power view showing us a single osteon, the Haversian canal containing the nerves and capillaries, and the concentric lamellae here, and in the lamellae we can see the osteocyte cells which are placed in the lacunae. Longitudinal section of compact bone. Haversian canals here run parallel to each other and are surrounded by parallelly arranged sections of concentric lamellae. Folkman's canals run obliquely and connect adjacent Haversian canals. This here is a low power view of a longitudinal section of compact bone, and what we see here are the Haversian canals which are running parallel to each other, and we also see obliquely running Folkman's canals which are connecting adjacent Haversian canals. Folkman's canals are well appreciated in a longitudinal section of compact bone. Also seen here are parallelly running concentric lamellae around the Haversian canals. A high power view here showing you the Haversian canal running parallel to each other and the Folkman's canal which obliquely runs and connects adjacent Haversian canals. Also seen here are parallelly running concentric lamellae containing the osteocyte cells. Other types of lamellae are interstitial lamellae. Between adjacent osteons, fragments of older osteons are seen. The lamellar arrangement of these older osteons is called interstitial lamellae. Between adjacent interstitial lamellae, lacunae and radiating canaliculi are seen. Circumferential lamellae. These are of two types. Outer circumferential lamella lies just beneath the periosteum on the outer surface of the bone. Inner circumferential lamella lies deep to the endosteum and encircles the marrow cavity. Periosteum. Bone is covered externally by a membrane called periosteum. It has two layers, outer fibrous and inner cellular layers. Outer fibrous layer is made up of collagen fibers. Inner cellular layer shows presence of osteogenic cells. It is highly vascular. Vessels and lymphatics of periosteum are connected to the vessels of Haversian canal by the Folkman's canals. Endosteum. It is a lining that covers the inner surface of bone that faces the marrow cavity and the spaces of spongy bones. It is lined by a single cell thick layer of osteoblasts, osteoclasts and resting flat squamous cells. Compact bone transverse section. The salient features for spotting here would be presence of Haversian canal, Haversian canal containing blood vessels, and presence of different types of lamellae. While for the compact bone longitudinal section, the salient features for spotting will be presence of longitudinal sections of Haversian canal, presence of horizontal or oblique sections of Folkman's canals, presence of lamellae running parallel to Haversian canal. What are the sites where we see compact bone? Diaphysis of long bone, outer thin covering of epiphysis of long bones, outer and inner tables of flat bones, and outer thin layer of all other bones. Let us now see the differences between compact bone transverse section and compact bone longitudinal section. In the transverse section, we see oval or circular Haversian canal, while in the longitudinal section, the Haversian canals run parallel to each other. In the transverse section, the Haversian canal is surrounded by concentric lamellae, while in the longitudinal section, the Haversian canal is surrounded by parallelly arranged sections of concentric lamellae. The circumferential lamellae are well appreciated in the transverse section, while they are not appreciated in the longitudinal section. Now let us see the differences between histology of cartilage and bone. The connective tissue in cartilage is soft, while in bone it is hard. The features: cartilage is flexible and soft elastic, while bone is rigid, non-flexible and tough. Cartilage grows unidirectionally, while the bone grows bidirectionally. Haversian system and Folkman's canals are absent in the cartilage, while they are present in the bone tissue. The bone marrow is absent in cartilage tissue, while it is present in the bone tissue. Lacunae that are seen in the cartilage have 2 to 3 chondrocytes, while the lacunae that are seen in bone tissue have canaliculi, with each lacuna containing only one osteocyte. The cells that are seen in the cartilage are known as chondrocytes. In bone, we see 4 types of cells, but predominantly we see osteocytes. The matrix of the cartilage is organic, homogeneous mass without lamellae and does not possess calcium salts, while the bone matrix is organic and inorganic, occurs in lamellae, is vascular with calcium phosphate deposits. The coverings of the cartilage are called as perichondrium, while those of bone are called as periosteum. The types cartilage are of 3 types: hyaline, elastic and fibrocartilage, while bone is of 2 types: compact and spongy. Thus, we have seen the histology of bone tissue. We saw the various types of bone cells. We studied the 2 basic slides for bone tissue, which are compact bone transverse section and compact bone longitudinal section. We also saw the difference between these 2 slides, and since we have already studied the histology of cartilage, we also saw how to differentiate cartilage from bone tissue histologically. For further reference, you can go through Sontakke Yogesh, Textbook of Human Histology, CBS Publishers and Distributors Private Limited, New Delhi, 2020, page numbers 77 to 91. Thank you.